Hello, this is the Bite Weasel, and in this video we'll be starting a brand new mini-series. This time we'll be looking at how to make a Roblox Obby game from scratch. So here I have the base plate template with absolutely nothing on it, and this is what we're going to use to build our Obby. Now we need to think about what sort of obstacles we want to add to our game for the player to traverse so that they can get to the end and then win the game. Now, the most basic of all obstacles is, of course, the jumping platforms. These require no scripting at all, so they're super easy to add, but they are still kind of fun. So we'll do that first, but we have to think about which direction do we need to build our obby in. Well, we really want to match whatever direction the player spawns in when they join the game. And that we can figure out using this cube. So this cube sort of has words on each face that correspond to that particular direction in the world. So you see here's the left, here's the back, and on the other side there's the front. And so a player will always spawn in facing the front. So this means we want the cube so that we can see the back, because on the other side of the cube facing that way is the front. So we'll start building at the back of the cube all the way over to the front of the cube. So that means we want to build our platforms in that direction. So how do we make platforms? Really easy. You just add a new part and make sure that this part is anchored with the anchor button right here. And what that's going to do is it's basically going to make this part stay static in the world instead of being affected by gravity and sort of falling down into the void. So whenever you add a new part like that, make sure you do the anchored property either here or in the actual property window so that you can keep the part exactly where you want it. Unless, of course, you're making something that sort of moves like a bullet, something like that. So for now, we'll just create these things and sort of use these move and scale buttons to make our moving platforms. I'm pressing Control D here to duplicate so that I can move it out and have a set of jumping platforms. The last one we'll make a bit wider, make it a sort of safe space, and maybe change the color to green to sort of indicate that, yep, you've done, that's the end of the stage, now you're in a safe spot. Right? And you can, of course, take more time than I'm going to in your game to make it look good. We can just sort of change these colors around. And so there we go. We have now a very basic obby. So the player will need to jump between these platforms to get to the end, and then they'll win. Yay! Obviously, it's super easy because if you fall off, absolutely nothing happens right now. So the way to fix that is, of course, come to the base plate in the workspace and just press delete. And now it's much, much more dangerous because if I mess up here, I'm going to fall off the world like this. Wah! Fall into the void. Make me lose all my health points, and then respawn back at the beginning. So there we go. We've finished an amazing obby. Ta-da, we're done. You can stop the video, upload your game, and you're ready to go. Just kidding, of course. But that is Area 1. So what we can do is sort of move these things into a folder to indicate that this part of the obby, is my first obstacle, Area 1. And then we can make a second area, that's Area 2 and Area 3 and so on, and keep the hierarchy in here in our workspace all nice and neat. So what we can do is select all these parts, right-click, and choose Group as Folder. And basically what that does is it puts all of those things into this nice container here so that you can collapse it when you're no longer looking at it, and it keeps your hierarchy a little easier to manage. The other thing I want to do is sort of rename this safe part so that I know it is like the ending of this particular stage. So we'll call it stage, and we can rename this folder here, maybe Area 1, because that's the first obstacle, our first area that the player has to traverse. So there we go. Nice. Now we can sort of duplicate this entire folder to make a second area. So we can click it, Control D, maybe rename it to Area 2, and then move that entire thing over here. So already we've got a double size obby just by duplicating an entire folder here. So this is nice, but I think we're going to look at a different kind of obstacle. So instead of a jumping platform, we're going to do the next kind of obstacle that's very common in these things, and that is having to avoid getting damaged by some sort of damage brick or a lava brick or some sort of part that when you touch it actually does damage to you. So the easiest way to do that is to just take this thing, duplicate a little version of it. Whoops. If I actually go press the keybind, duplicate a little version of it and sort of change this color to maybe red to show danger. And then we'll start adding some scripting to make it clear that these are going to damage you when you touch them. Right? So we can duplicate this, we can move it around and sort of make it, whoops, a little more complicated for our player to navigate. So something like this, of course, again, take more time when you do it, so that it's more challenging, more exciting to look at. But there you go. We have a second area now with different parts in it. So now if I get all the way over there, assuming I don't mess up these jumps. Whoops. Of course I did. I am so terrible at obbies. In fact, what I'm going to do is I'm just going to cheat. Don't tell anyone. But for testing, what I'm going to do, I'm just going to duplicate this. And I'm going to move a piece all the way down so that it's safe for me to cross. Obviously, don't keep that there for your obby or it makes it trivial. But for me, that's going to be useful for testing. So now we can get to our second area. But these bricks don't actually hurt us, right? The idea is I navigate all the way or I jump over to the end. But right now, it's completely safe if I touch them. So let's fix that part by adding some script. Now, depending on which sort of tutorial you are watching, you'll find many different ways to sort of add scripting behavior to parts like these damage bricks. One thing that you might see is someone to say, okay, click the part, click this little plus button and add a script to the part. And then that script can get a reference to its part that it's attached to by simply going script.parent. Now you have access to the brick itself, and you can add whatever sort of code you need here, which would really be a touch event. So when the player touches it, they get damaged. Now you could do it this way. You could have a script in each individual part. The problem with doing this is if I decide that I want the behavior to be different, so instead of destroying the player outright, I only want to damage them a little bit. If I have a script directly in the part, it means that I would need to take that script and I would need to paste it into all of these other parts, right? And so whenever I make a change, I'm going to have to change it not just in one space, but in 2, 3, 4, however many different parts you have. So I almost never recommend adding a script directly to a part like that. Instead, because we want it to happen on the server, I would go down to the server script service and add your script here. And so this is going to be something like our damage script. So instead of having individual scripts in each part, we're going to have one script that controls them all. This means if we end up coming back and deciding that our bricks should behave in a slightly different way, we only need to change it in one place. Great. Now we just need a reference to all these bricks. And so we could do that by looking in our workspace, grabbing the area folder that we know has these bricks in, and then looking at each child under there to grab the bricks. And that would work. But the problem is, what if we then decided to make area 3 that also had some sort of damage bricks in them? Well, we'd have to go through and change our code to not only look through area 2 now, but also area 3. And we don't really want to go ahead and have to change our code constantly when we're just sort of adding to our obby. So instead of doing it that way and grabbing the workspace folder and looking through there, instead, we're going to use a thing called the collection service. Now, if you've ever watched any of my other videos, you'll know that I'm a big fan of the collection service, so we're going to use it here again. And it's basically a service that you can use in your script to ask Roblox, hey, what are all the parts that have a particular tag? And that's how the collection service works. So instead of looking through your workspace to find things, it can look through all your entire hierarchy really quickly for anything with a particular tag. So what we need to do first is select all of these bricks that are red and add a tag to them so the collection service can find them. So down here in the properties window, we can add a new tag and we'll call it damage, because anything tagged with damage is going to damage the player. And another thing we can sort of do just to make our hierarchy a little bit nicer is go over here and change the name of all these things to like, I don't know, lava brick. And now we can see which bits are the lava brick, which bit is the floor, and which bit is the ending stage. So that's nice. Not really required, but it makes it look easier for when you come back and trying to figure out what on earth you were thinking about for area 2. So there we go. Each one of these things is now tagged with damage. And we want to look up that in our script. That's how we will get a reference to each one of these lava bricks. So the first thing we need to do is get access to that collection service. So the way that you do that in Roblox is use the game variable that's built in, :get service, and then give it a string that is the name of the service. And we want the collection service. Now that's going to return the service, so we can make that equal to a local variable. Local collection service equals game get service collection service. Nice. Now the collection service has this nice function on it that you can call called get tagged. And that returns all of the items in your entire hierarchy that have the tag, and the tag we want to use is damage. So now that we get all of those damage bricks, we're going to loop through them in a simple for loop. So we can say for I underscore in collection service get tagged, do something. Right? So that's going to loop through. Actually, I've done that the wrong way around. underscore I. That's going to grab everything from this array, but we don't care about the index in the array. We actually care about the item itself, right? The actual brick, not that it's the first brick, second brick, third brick. We care that it is the brick, right? And from there, we need to add a touch event. So if the player touches it, they get hurt. So we can add a new local function to do that for us. I'm having a bad time typing today. We can say on added, and that can be an item. And here we will add our touch event. So when we're going through the loop, we can call this new function and pass in that particular brick, which is whatever's in the array. So now how do you add a touch event to something? Well, each individual base part has an item on it called touched. Now what you'll notice though is when I press dot, I didn't get any nice IntelliSense. I have no idea what this item has on it. And that's because Roblox Studio does not know what type this is. It could be anything. It could be a number, could be a string, could be a collection service for all it knows. The way that you can tell Roblox what type this is with a colon. And then you could do space and you can list out what kind of type this item is. So for us, we're going to say it's a base part because we know each one of these lava bricks that we're looping through is going to be a base part. And now if I do dot, you'll see that I get some nice IntelliSense and I can figure out that item has a touched signal on it. And this fires when a part touches another part, right? Which is exactly what we want. We want to figure out when a player touches this lava brick item. So we can do dot touched, and then we can listen to that event firing using the connect function. We pass in a function here, and that function is going to be passed the other part that touched us. So whenever this touched event fires, we'll get sent in the other part that touched us. This is really handy because now we can figure out which player it was that touched us, right? And we can do that by taking the other part, which is probably like a leg or an arm or maybe a head, depending on how the player landed on the brick. We need to find the actual player character themselves. And so if it's a leg or an arm or a head, the player's actual character is the parent of that leg. So you can say other part.parent, and that will be the sort of character of whoever touched you, right? But it might not have actually been a player that touched you. It could have been something else. It could have been like someone threw a part on top of these bricks that doesn't have a parent. So you have to be very careful here. And the way that we can prevent our script from breaking is to check that this character is what we expect it to be. So we can say if not character, then, whoops, misspelling there, return early. And this will work good for us because now we're going to grab the parent of this, what we hope is a leg, to give us back the character. But if there's not a character, if this is nil, then we're going to return early. So the rest of this script can continue on knowing that if the character was invalid, we've already returned early and skipped out of the rest of this. So this sort of mechanism is called a guard check, and we use it a lot so that we know that at the bottom of the script, the variables that we're using are, in fact, exactly what we think they are. So now that we've got the character, we can check that it's actually a human character, because it could be something else. It could be some weird NPC. It could be a bullet that landed on us. Who knows? So to do that, we can find a part on this character, which is a humanoid, right? So find the first child of this character, which is a humanoid. Only players have humanoids. So we can say humanoid equals that. And then we'll do another guard check. If not humanoid, because we couldn't find it, because it was some other item, not a player, then return early. Otherwise, we can now sort of damage this humanoid. And there's two ways to do it. You can say take damage and pass in some value, like maybe all your bricks want to do 10 damage. So if you touch them, you do not die immediately. Instead, you just take some damage on your health bar, and only when it reaches 0 do you actually die. So we could do that. Or if you prefer and you just want to have the player die outright, you can say .health equals 0. So this will be an immediately damage killing brick. The other one will just be a damaging brick. But this should work. So we're using the collection service to find all of those things that are tagged with damage. Then we're adding a touch event. We're making sure that the thing that touched us is a character, and the character has a humanoid on it. And then if so, we're setting their health to 0. So now if I try it, and I run all the way over here, if I touch one of these bricks now, in theory, I should, yep, I lose all my health, and I respawn back at the beginning. So there we go. You've already got a nice way of setting these things up. You only have a single script. You don't have it all over the place. So if I did decide that I don't want to die immediately, instead I want to take only 10 damage, you can change it in one place, and now all your bricks will be changed like that. So now if I touch it, you'll see I take some damage, but I don't die until I touch it enough that I've run out of health entirely. And then I do die. So touch events trigger as you walk over them over and over again, which is why when I walk over it, I take a bunch of damage, right? So just be aware of that. If you don't want that to happen, you sort of have to change this to have a thing called a debounce. And the way that debounces work is you basically set some value to be true or false, and then only do this when it's false, right? I'll show you a quick way of doing that. Basically, you need some sort of state. So this is like damage items. We'll do that. And then when someone first touches on something, you say damage items item equals true. But before that, you'll say, well, if there's already a damage item here, then don't do it. Then return early. Otherwise, we'll set it to true. Then we'll wait a little bit. So maybe wait 1 second. Then we'll set it back to false. And that's a debounce. So what's happening here is basically we're finding the character, the humanoid, making sure all that's good. And then the first time it comes in here, this is going to be false, so it's going to go down here, going to set it to true and make them take damage. But then if another touch event comes in, before this is finished waiting, this will still be true, so we'll return early. So the second set of damage will not happen until the debounce is finished and we set it back to false. So you can see that what that looks like now, if you want this sort of behavior, is if I walk over it, I just take 1 damage until that 1 second has passed, and then I can touch it again. So if I stay standing on it, it's not going to trigger another touch event until I move and a different part of my foot sort of touches it again. But there you go. So that's how you can do a quick debounce. if you want to only take a little bit of damage as they walk over these things. That's up to you. So, of course, your game may be designed differently, however you want it. So do take that into consideration if you want to debounce or not. So there we go. We've got Area 1 that has these jumping platforms. We've got Area 2 that has these damage bricks. But I haven't really shown you yet the power of the collection service. So let's do that next with a brand new area. So Area 1, Area 2. Let's duplicate Area 2. Move it over here. Rename it, of course, Area 3. That makes sense. 1, 2, 3. So now, instead of these bricks living here whenever you join the game and just being there in the hierarchy, what we're going to do is we're going to sort of generate those bricks at runtime. And this will show you how powerful the collection service is based on this tagging mechanism that it uses. So right now, it's getting all the things that are tagged with damage. So let's generate some bricks at runtime that also have that damage tag and see what that looks like. So what I'm going to do is I'm going to duplicate this and I'm going to make a really small sort of turret. So of course you should spend way longer doing this than I'm going to, because otherwise it's just going to look terrible in your game and we don't want that. Just my videos look terrible. That is fine. So there we go. We've got a sort of orange turret here, so maybe we should change its color. And a turret barrel. Let's change this to be, I don't know, black, I guess. This can be some sort of blue. Sure, cool. So these two things together now are a turret. So what you can do if you really want to is right-click this and group as model. So this is another way of sort of cleaning up your hierarchy. Instead of using a folder, though, that has a bunch of different parts and is really just a way of collecting a bunch of those things together, a model is actually a physical item. And so it has a bunch of properties on here that you would get with a base part. So models are slightly different to folders, but they are another way of collecting these things together. And it's very important that here we use a model so that we can actually figure out which way this model is facing and where it is positioned in the world. Folders don't really have that stuff because they are not a real physical item. They are just a way of storing things together in your hierarchy. But models do. So we could rename this model our turret. And I think the most important part of our turret is the barrel. So we'll rename this barrel. Now, another important thing about models is that they need a primary part. So models themselves can't add a touch event or a collide event or anything. Instead, they need to be pointed at a base part that does. So you can go down here in your model to primary part, and you can point it at that body of the turret. So that's what this part is. So we can rename this like base. So that's the base of the turret. This is the barrel of the turret, and we are pretty good to go with our turret. Now, what we're going to do is make our turret obviously shoot a brick, and that brick is going to be tagged with damage. So we can go on here and we can sort of use the collection service again by adding a tag to our barrel and calling it shooter, right? That's going to be the name of this tag. And we can create a brand new script. And that script is going to be called shooters. And so anything tagged with a shooter will actually generate a damage brick in a particular direction. So this is going to be nice. What we can do, though, is because we've already sort of used the collection service once, we can copy this. In fact, let me just zoom in a little bit too. We can copy this and paste it into our new shooter code and just sort of modify it a bit. So here we were looking through the collection service. We were finding everything that had the damage tag. Now we want everything that has the shooter tag. And instead of actually doing this and sort of adding a touch event, instead, what we're going to want to do is have a loop that constantly finds every shooter in our game and after like 3 seconds makes them generate a bullet, right? So we don't actually need to do it exactly how we did in our damage script. This is going to show you another way of sort of doing something over and over again. Well, if you want something to happen over and over again in Lua, you can basically use a while true loop. So while true, do something, and that's going to be basically looking for all of our shooters. And when we find one, we want it to fire bullet, right? Instead of adding something like the touch event, we're going to have a new local function called fire bullet. Whoops, not fire button. That would be an interesting mechanic. Instead, we're going to have it fire a bullet, and that is what's going to happen over and over again. Now, this while true loop is going to constantly run over and over again, which means that it's never actually going to get to the end because this condition is always true. So if I was to write something here like print hello, we would never, ever, ever see the word hello in our output window because this loop goes on forever and it never ends. So if you want to prevent that and you want other parts of your script to continue running, instead of doing it directly in the script here, what we need to do is make Roblox add a new thread for us. And a thread is basically a different part of the function that can run in parallel with any other thread in the game. So all your scripts have their own thread, but you can make another thread inside that basically looks like this. We'll call task.spawn, and then we'll move all of this stuff inside that function that task is running. So now we would see hello because task.spawn does not block the thread. It continues down here, but on the new thread, that is going to constantly run this loop. So that's really nice. And now inside here, just like we did with our debounce, we can sort of wait several seconds before we actually make the shooters shoot a bullet. So there we go. We have this script that's going to find all of our shooters every 2 seconds. It's going to find all of our shooters and then make them fire a bullet. Now we just need our fire bullet code to actually do something. So what we need to do is generate a new bullet that is going to be tagged with damage, right? So we can do that by saying local bullet equals instance.new, and what we need to do is give it a part. That's what we want to instantiate. So we're going to have a new part, and then we're going to say that bullet size is going to be a new vector 3 of size 1, 1, 1. So it's going to be like a small square bullet. We're going to set that bullet's position to be the same as whichever item fire does. So this is going to be the shooter that we're looping through. So we can say position equals item dot position. And then we can add it into our workspace by saying bullet.parent equals workspace, or we could make a new folder perhaps that all our bullets go into, but this is fine for now. So that's going to add a bullet directly into our workspace. We can give it a name too, so that we can see when it's in our workspace what this particular part is. So we can say bullet. Now we need to actually make it move. So how can we do that? Well, base parts have something on them called the assembly linear velocity. And this is basically the direction in which the item should continue to move. So I'm going to say I want it to move to the left with -1, and then we can sort of multiply that vector with however fast we want the bullet to move. So let's just say 100 for now. But if I test the game now, what we should see is if I run over there and I avoid these damage bricks as best I can, ow, not very good, you should see that that bullet is being shot out into the world in the left direction. Very nice, pretty easy, right? Unfortunately, right now, it's not actually damaging me. It is hitting me because the physics calculations are still doing that, but it's not actually big enough to push me off the world, and it's not doing any damage. Okay, so we have our bullet. We want it to do damage, though. So we have a script right here that does damage. Right here, called our damage script. So what we could do is we could take all of this function that adds a touch event that does the damage and paste it in here onto our bullet. But that doesn't make sense. We're going to use the power of the collection service to do it for us. So the way that we do that is we just tag this bullet with that damage tag. So we can say add tag, pass in the word damage, because that's the name of the tag we want. And now this bullet, when it gets created, is going to be tagged with damage. Now the collection service doesn't actually know about that yet. We're only running this loop to find all the bricks once. But the collection service has us covered because it has another thing on it called get instance added signal. And this, much like the touch event, is an event that will fire whenever a particular tag is added into the world, right? So whenever an item with the damage tag is added into the world, we're going to connect up to the listener to get told about that item. And this is going to give us that item that we know has been tagged. So we can say it's an item and the type is a base part because that's exactly what we've tagged our bullet with, damage, and the bullet is a base part. Now we can say on added item, and that is going to call this script whenever our bullet gets added into the world. So even though the tag is coming from a completely different script, and this script knows nothing about this script, and this script knows nothing about this script, it's still going to work because we've added a tag, and now the collection service is going to say, oh, a new item was added with this tag. Let's call this handler. So now if I go to that, what we should see is if I go all the way to area 3, I guess, these newly generated bullets, are going to start doing damage. Ouch. They also still bounce off me. So what we can do there is change it, instead of adding physics collisions, we can say can collide equals false. So now it won't actually physically hit me, but it can still touch me with the touch event. And just to double make sure that it's true, we can say can touch equals true. Right, so can collide is false, no longer going to bounce off me with physics calculations, but can touch is going to be true. So that's cool. But what you might notice is in this workspace, these bullets are lasting kind of a long time. In fact, you can see it all the way down there. They're only getting destroyed when they fall into the void. And so maybe you don't want that. Maybe you want them to get destroyed much quicker so you don't have all of these bullets, living for a very long time, especially if you start having multiple turrets. And a way to fix that is with a new service. So this is also a really handy service. It's called the debris service. What you can do is you can call local debris equals game get service, and then the name of the service is debris service. And you can add anything to the debris service, and it will basically get destroyed after a certain amount of time. So you can say, add item to the debris service, the bullet, and I want it to get destroyed after half a second. And now if I play the game and we look over at those bullets, you should see that instead of falling all the way into the void, they're getting destroyed around here. So half a second after they're alive, they get destroyed. So now they won't clog up our workspace, even if we have a bunch of these turrets. And the great thing about these tags and the way that the collection service works is we can just make more of these turrets, right? We can duplicate these things. And now we've got 3 turrets all shooting. Cool. I did absolutely nothing except Control D, and now they all shoot out bullets. Now, because of the way our script works, they all shoot at the exact same time, which maybe you want, maybe you don't want. Kind of means you have to go through it like that, which is pretty cool. But there are many ways to customize things. One of the ways that I like to customize things is actually inside our hierarchy, where we've added the shooter tag. I also would add an attribute. Now, attributes are very similar to tags in that you can add them to pretty much anything. The main difference is a tag is either there or it isn't. An attribute, though, can have a value. So we could customize each one of these turrets with a value that indicates how often they would shoot. So let's add an attribute here and change it to a number. Since we're going to want to do some mathematical calculations on it, we'll have a number attribute and we'll call it FireRate, right? How often this is going to fire. And so I'll say, this one should fire every 0.5 of a second. And these other two, I'm going to add attributes to them. Sorry, make sure it's the barrel. Make sure it is a number. Set it to FireRate. And I'll say these ones want to fire every 2 seconds. Right? It doesn't really matter. You can go away and you can customize each one of these individually if you like. The important point is we need to use this attribute now inside our shooter script. So in a very similar way to our damage script where we added some state, we're going to need some state for each one of our shooters. So we'll say shooters equals a new table. And then what we'll do is instead of waiting 2 seconds, we'll wait 0.1 of a second. And instead of immediately firing a bullet, what we'll do is we'll take the shooters and we will add a value into those shooters and say plus equals 0.1. And then we'll say if shooters I, so from our shooters table, this particular item is greater than their fire rate, then shoot a bullet, right? Then shoot a bullet. End. Now, how do we get the fire rate? Well, we can say local fire rate equals I get attribute. And then the name of the attribute is the one we gave it over there, which is fire rate. Oops. So now it's going to loop through, and for each item tagged shooter, it's going to add 0.1 to the value in our state table. And when it reaches greater than the fire rate, it's going to fire a bullet. Then we also need to reset that back to 0, so it goes over and over again. So this is just one way of sort of doing it. Now, it is going to cause a problem because this will not always be in the table. The first time we come to this loop ever, we're going to get shooter's I. There is no shooter in that table, so this is going to be nil, and you cannot add 0.1 to nil. We just need to do a little bit of cleanup here that says if not shooters I, then why am I misspelling everything? Then shooters I equals 0, right? So we're just going to make sure that there's always an entry in the table and it starts at 0. Then we're going to add 0.1 to it, keep going until it hits the fire rate, fires a bullet, and resets it. So now if I play the game, what we should see is that those are now firing at completely different rates. Well, 2 of them should fire at the same time. So one of them is firing every half a second, and the other 2 are firing every, what did we set it to? 2 seconds? So you can see that is working. But now we can customize that. So I think probably half a second is way too hard, especially for me. I'm terrible at this sort of game. So we can have the first one shoot every 2 seconds, this one shoot every 3 seconds, and the last one shoot every 2.5 seconds, or whatever, right? You can customize this in your game. And so that's just one way of sort of adding customizations to individual items, is using an attribute and then looking up that attribute inside your script. So now we've got 3 cool areas. We've got this jumping platform that I'm sort of cheating over. We've got this damage platform that you just jump over or navigate through. And then we've got this firing place that fires at different rates. And then if you do get hit, you take damage. So that's pretty cool. Now you could go through and you could clean this up a bit. Like we could, for example, change the color of our bullet by saying brick color equals, brick color.red or something. So now all our bullets are red. And we could also make it so that the bullets actually fire in the correct direction instead of always to the left. So right now, if I was to duplicate one of these turrets, move it this way, and sort of rotate it around, it's still going to fire out to the left because we've sort of hard-coded that. Right? We don't really want that. Instead, what we want to do is use the heading of this part as the direction in which to fire. Right? So by default, they're going to fire to the left. But if they've been rotated, we need to rotate that direction in which they're firing. So to do that, let's modify our code here where we generate this direction. So what we need to do is grab the item, which is our shooter, and grab its C frame. Now, a C-frame, I think, stands for coordinate frame, and it's basically a position and rotation of something in the world. So we get the C-frame, and what we really want is to figure out the direction in which the C-frame is facing in a sort of vector 3 way. So we already have a vector 3 that points to the left. We need a vector 3 that points to whichever direction this C-frame is pointing in. So one way you can do that, and there are kind of multiple ways, is to use a vector to world space. And what this is going to do is we're going to change this vector that's always pointing to the left into the world direction that this thing is facing. So we can say local direction equals this. And so instead of firing all the way to the left, we'll fire in that direction, but still the same speed. So now if I view it, we should see that the turrets fire in both directions, depending on which way around they are rotated. You see these ones are firing over here, and this one is firing this way. It's kind of hard to see, but it is definitely working. Whoops, of all the things to do. Yeah, so it is working, and we should be able to get hit on either side of those turrets now. Luckily, they only do a bit of damage, so it's not too bad. But you can see that this one is firing, and it's hitting me as it goes past. So there you go. The power of collection service. So one other thing I did want to mention about the collection service is that here we're using a get instance added signal for when anything with this particular tag, aka damage, gets added into the world. It will fire our handler here. Well, there is an equivalent for when something with that tag gets removed from the world. So you can see here, not only is there a get added signal, but there is a get removed signal. Okay? And so if we were to use this one, this function would get called whenever something with this tag gets removed from the world. Now for DamageBricks, that doesn't really matter. But for the shooters, when we create a bullet with that tag, what's happening is we're using the debris service to sort of destroy that bullet after half a second. And what I want to make sure is that when that bullet gets removed from the world, we sort of clean up any of this state that we're using for debouncing so that this state table doesn't become clogged up with bullet state that no longer exists because the bullet went away. So what we can do is we can listen to this removed signal and we can change it from on added to an on removed sort of function. And then we can create a local function called on removed. It can take in an item, which is a base part, just like we did before. But now, instead of doing anything with the touch event, we'll just make sure to clean up that state by setting anything in the damage items table that matches that item is set to nil. And this will sort of clear it out. So this makes sure that as we fire bullets and they sort of get destroyed by falling off the end of the world, we don't clog up our memory by filling up this table and never removing it. So that's a handy thing with the collection service too. The added signal, of course, very useful, but now a removed signal as well. And now we've already got 3 different areas: jumping platforms, these damage bricks, and now these turrets that do actually shoot at different rates at the player. And you can sort of duplicate these as much as you want, right? Make this as easy or as difficult as you want for these things. And of course, customization is all abound. You just customize that attribute on the barrel to say how often you want this to shoot. Another customization we could do is change our hard-coded value of 10 damage. So right now in our damage script, anything that has the tag damage will always cause 10 damage. Maybe we want to customize that. And maybe we want to look it up the same way that we sort of look up the fire rate from individual turrets. So we can add an attribute called damage amount and look that up on any item that has the damage tag. So to do that would be quite easy. We would just say local amount equals item, which is the item that has the damage tag, get attribute, and then the name of the attribute we want to look up. So we could call it damage amount. And now we could pass that in instead of the hard-coded value 10. But right now, not everything that is tagged with damage has a damage amount attribute. So we could add a nice sort of default value here by saying if not amount, then amount equals 10, right? The same value that we had before. So now if something doesn't have a customized damage amount attribute, it'll get set to 10 just like before. But we could go through these lava bricks and customize them. Or in this case, we could sort of add the attribute here to our bullet. So we could say bullet set attribute damage amount, and we could set it to something like 100. So if you get shot by a bullet, you will die immediately. But if you stand on a damage brick, you will only take a small amount of damage, the default value of 10. Right? But now if I stand over here, I get shot by one of these things. Oh dear, I took 100 damage straight away. So that's another way to customize it. And of course, the way that we're doing our shooter script is that it comes from a shooter tag down here with an attribute FireRate. There's nothing stopping us from adding a new attribute, in fact, to all of these things. Doop-be-doop-be-doop. Like this. They add a new attribute, call it damage amount, set it to a number, and set that to, say, 50. Right? And then pass that attribute along to where we create the bullet. So instead of hard coding here, you could say item, get attribute, damage amount. So now if it's a shooter, you can have a damage amount, and that's how much damage the bullet will cause. And if you're a regular damage item, you can have a damage amount attribute, and that will be how much damage you cause when someone touches you. So that's pretty straightforward. You can use the attribute system to customize lots and lots of different parts of your script. Here we're using it for both the fire rate, how often these things fire, and the actual damage from things tagged with damage. So you can think of probably lots of different mechanics that can use attributes. But one thing that sort of annoys me right now is that these bullets are sort of affected by gravity. You can see that they're sort of arcing down. I kind of want these turrets to shoot more like laser beams, where these things are sort of locked in the y-axis instead of falling down in an arc. So let me just show you what that looks like. Back in our shooter script, we're currently sort of creating our bullet with an assembly linear velocity. And this is basically like a velocity that is affected by other forces in the system. So you give it a velocity and it will sort of combine that with other effects from physics, such as gravity and collisions and all sorts of stuff like that. Instead of doing that, to do something a little less realistic, you can use a thing that isn't the assembly linear velocity, but is an item called the linear velocity. I know it's confusing, they have a very similar name, but they are different things. So the way that you can create a linear velocity is similar to how we created the part in the first place, which is using instance.new. And you can say that you want a new linear velocity, right? And this is an item that doesn't really combine with other physics forces. It is indeed just its own force that gets applied, and then everything else sort of gets ignored. So we can grab that. We can say local LV equals linear velocity. Now, what we could also do is use this comma to send in a second parameter, which is the parent that this new instance should have when it gets created. So we're going to say bullet. So this will create a linear velocity directly on the bullet. And then we can say LV dot vector velocity equals that direction we already calculated multiplied by the speed, which I guess we've hard-coded at 100 here. But of course, this could be another place where you sort of grab an attribute from for customization. But we're just going to leave it as 100 for now. And then you can say LV dot max force equals, and then we need some really, really big number. So Roblox here has sort of suggested math dot huge, like as big as you can get. Like we don't want a maximum force where then this velocity breaks and it goes into regular calculations. We just want to force it to have this velocity forever. So we can pick the biggest number Roblox knows about to set it as the max. So we'll never hit it as math.huge. And then the very final thing that you need to do is a linear velocity needs an attachment point. Now, attachments are sort of like little items that you can add to any sort of part in your game, and they just have a position and a rotation, and that's really all they are. They don't have any way of physically viewing them at runtime. They're just basically a point in your part that sort of other things can attach to. So we can set this to be a new one. So we can say instance.new, give it an attachment, that's what we want to create, and we want that one to also be attached to the bullet. So this is going to create a new attachment on the bullet, and we're going to set our linear velocity's attachment 0 to that thing. So this is just a mechanism of sort of creating a part that will move in a velocity, in a linear sort of fashion, without being affected by other forces. So if I was to play the game now, what we should see over there is the bullets are traveling in a straight line, that exact velocity that we calculated without dropping down. And so if we wanted to make them look a little more like laser beams, we could just sort of change the size here. So maybe 3 wide instead of 1. And there you go. Now we've got sort of shooting turret laser beams. And these damage bricks sort of hurt me a little bit, but then these laser beams sort of hurt me quite a lot. 50, and then I die straight away. And if you're wondering why one bullet is causing more than 50 damage, well, it's due to our debounce. So because we made the bullets really long, when it's first striking one side of me, I'm getting damage, and before it's all the way through the other side of me, this debounce is resetting, and I'm getting another set of damage from the tail end of that same bullet. So we can sort of just update this. And you'll have to customize all of these numbers for your game, depending on how much damage you want, like what the distances between your turrets are, and how you've sort of set up your game. But I think having the numbers there and understanding how this stuff works should be quite easy for you to then customize. So you see here, I stood there, I only took one set of 50 damage. And again, one set because we've reset. And there you go. That's pretty much our first episode for this obby. Now we will be continuing to add some more mechanics and some more obby related features. So stay tuned for that in future episodes. So that's it for this video. Thanks for watching. If you enjoyed it, like and subscribe, leave a comment, ring that notification bell, all that good stuff, and I will see you next time.